Hi everyone, so now we've finished this revision sheet, what we can do is try some past paper questions linked to it. So let's start with this one. Covalent substances can be simple molecular covalent or giant covalent. Oxygen is also a simple molecular covalent substance. Draw a dot and cross diagram, I'm going to highlight that, it's dot and cross, for the molecule of oxygen. So a molecule of oxygen, which it said is O2. Okay, so what I'm going to do is go back to my handy sheet that I've got over here. And look, I've already drawn it on here. So all I need to do is draw the same diagram in this space. So I've got two O's for oxygen. I'll draw my circles first. I was caught out last time because I didn't do the overlap big enough. Okay, and we know that oxygen is in group 6, so it has 6 electrons in the outer shell. And it shares 2 of those. So on this side, 1, 2, 3, 4, 5, 6. And to make sure I've got 6 circles. 1, 2, 3, 4, 5, 6. And I have got 6 crosses. There you go. That's that answer there for 2 marks. Next question. Hydrogen sulfide, H2S, is a simple molecular covalent compound. A hydrogen atom has 1 electron in its outer shell. I'm going to highlight that. A sulfur atom has 6 electrons in its outer shell. Which of the following is the dot and cross diagram of a molecule of hydrogen sulfide? So a molecule of hydrogen sulfide. So we have a look at this. So if hydrogen has 1 and sulfur has 6, sulfur will need 2 more to make 8. So remember our 2, 8, 8, 2. That's how many electrons fit in the outer shell in the first, second, third and fourth shell. So if it has 6, it needs 2 more. That provides 1 from hydrogen. So there must be 2 hydrogens. So 2 hydrogens I must have and 1 sulfur. So we have a look at this. Oh yeah, so all of them have 2 hydrogens and 1 sulfur, and it needs to share the hydrogen. So I think this one, B, looks correct. It's a bit small on my paper, I'm really sorry, because I got a dot and cross here. So I've got dots around the sulfur. The dot must come from hydrogen. Sorry, the cross must come from hydrogen. So there's 1 there, 1 there, and then it says 6 electrons. 1, 2, 3, 4, 5, 6. So it must be B. Next one. Which row in figure 5 shows the properties of a simple molecular covalent compound such as hydrogen sulfide? So a simple molecular covalent compound, so it's small. Okay, if it's small, that means it doesn't take a lot of energy to boil it or to melt it. So I'm looking for something that's low. Here you go, I've got it. It's C there. It's also a poor conductor of electricity. Okay, so that's the only possible one that it can be. Next one. Nitrogen and oxygen are present in the air. Another gas present in the air is carbon dioxide, CO2. There are covalent bonds between the atoms in a molecule of carbon dioxide. Describe what is meant by a covalent bond, and it's out of 2 marks. So I'm going to put, this is where, let me just look back, hang on, I've got it in here. Something about sharing electron occurs between non-metals. So I'm going to put sharing pairs of electrons where pairs of electrons are shared. It occurs between atoms of non-metals. So that way I'm making sure that I'm going to get those 2 marks. I'm just putting all the information down there that I have. The electronic configuration of oxygen, atomic number 8, is 2.6. Right, I'm going to highlight that. So oxygen. give the electronic configuration of carbon atomic number 6. So the numbers have to add up to 6 in total. I'm going to get my trusty periodic table out. So we're looking for carbon. Now, because I've got here, look, carbon is in group 4, so therefore it's got 4 electrons in the outer shell, so 4 must be the last one. And then it's in period 2. You can see 1, 2 there, so that means it's got 2 electron shells. So that must be the second electron shell. If we go back here, remember we put 2, 8, 8, 2. So first must be 2, must be full, and then 4. And then we check, 2 plus 4 is 6. I'm certain that that's my answer. The next one, draw a dot and cross diagram. So I'm going to highlight dot and cross diagram of a molecule of carbon dioxide. Show the outer electrons only. Okay, I'm going to go back to my sheet. I have seen that before. I've drawn it there. So all I need to do is I need to copy that out because that is perfect there. Okay, so I am going to put my C at the top here, big circle, my O's overlapping. Not very good at drawing circles, I'm afraid, sorry. So 2 lots of dots and crosses in there. So double bonds between it. And then I'm going to make sure I've got 6 oxygens on the outside. Sorry, 6 electrons for oxygen. 1, 2, 3, 4, 5, 6. And same here. 1, 2, 3, 4, 5, 6. Brilliant. So there we go. My dot and cross diagram of carbon dioxide. The freezing point of water is 0 degrees. What is the structure of water? Well, it's not ionic. Ionic would have positives and negatives, so it can't be that. Simple molecular covalent. I mean, let's have a look. It's on our covalent bonding sheet, so water, so it must be simple meaning small, and it's covalent, so it must be that one. That is B. It's not giant covalent. Giant covalent would be something like diamond or graphite, and it's not metallic bonding. That happens between metals, and we know hydrogen and oxygen are not metals because they are found on this side of the periodic table, although hydrogen's kind of in the middle there, but we know oxygen is a non-metal. So there we go, all done.